Hello, how to solve this exponential problem? This is t to the power of t equals 7. We are solving for the value of t that satisfies this equation. That means the value of t that we are going to raise to the power of itself, that will give us 7. If you have t equals 1, that means if you have 1 power 1, this is 1 and that is not 7. If you consider t equals 2, that means you have 2 power 2. This will give you 4, and which is not 7. If you have t equals 3, that means you have 3 power 3. This will give you 27, and which is not 7. So we are looking for the value of t that we are going to raise to the power of itself that will give us 7. Now, after testing all this, we have discovered that none of this actually gives us 7, but we can get the range of the values of t from this testing that we have done. Remember, when t equals 2, we are having 4, and this is less than 7. And when t equals 3, we are having 27, and this is greater than 7. So we can say that the range of values of t is between 2 and 3. So we have 2 is less than t, while t itself is less than 3. So this is the range of values of t that will satisfy this equation. Now, to get that value, you can simply keep on testing. Now you know that the range is between 2 and 3. You can consider 2.1, 2.2, just like that, till you get the value. Now, but there's how you can actually solve this and get the value without testing for it. And that is what we are going to do in this video. So we make use of natural log of t over t, and we also have natural log of 7. And remember, if you have natural log of a power p, this is p times natural log of a. So that means you have t times natural log of t equals natural log of 7. So right here, what we can do is to solve this. How do we solve this? We make use of what we call the Olympiad function. So that function is represented with capital letter W. And you have the Olympiad function of an expression such as a times e to the power of a. What you are going to get will be a. And if you have the Olympiad function of x times e power x, what you get is x. So what we are going to do is to ensure that we manipulate this part of the equation to be in the form of this expression so that we can apply the Olympiad function. So for us to achieve that, let's recopy this t times ln t equals ln 7. Now what we are going to do will be to consider this identity. If you have e to the power of ln of x, this is just like writing x because the e can as well cancel the ln. Now I can replace this t here with e power ln t because the e can eliminate the ln. I'm going to be left with t because I'm trying to model this expression to be in this form. That's why I'm replacing the t with e power ln t. So that means this equation becomes, instead of writing t, I have e power ln t times ln t equals ln 7. Now gradually we are getting this expression, but the e comes before the e power a, so I need to do the same thing here, meaning the ln t here will come before the e power ln t. So what I'm going to have will be of ln t times e power ln t equals ln 7. Now what happens here is that what we have here is exactly what we have here. And at this point, we can apply the Lambert-Array function because it satisfies this condition in which the x is exactly what we have here. So that is the condition for the Lambert-Array function. So I need to apply the Lambert-Array function now of ln t times e power ln t, and this is the Lambert-Array function of ln 7. Now, like what happened here, after applying the Lambert-Array function, the x was the output here. So applying this Lambert-Array function here, we have output of ln t, and this equals the Lambert-Array function of ln 7. Now, since we are solving for t, I need to eliminate this ln, and I can do that using e. I have e power ln t equals e power the Lambert-Array function of ln 7. So the ln eliminated e, and what I have here is just t equals e power the Lambert-Array function of ln 7. Now what happens here is that I can easily replace this. If you don't get this in your calculator, if you cannot find this Lambert-Array function in your calculator, because this is what you need to type into your calculator to give you the value. Now, if you cannot get this Lambert-Array function icon in your calculator, what you are going to do will be to replace it with what we call the product log. T equals e power the product log. Product log is simply another name for the Lambert-Array function. It is what is more common compared to the Lambert-Array function. So you have e power the product log of ln 7. Now, once you type in this into your calculator, you will have an approximate value of t that will satisfy that equation. In this case, it's about 2.31. Then you have 65 into 4 decimal places. So you have e raised to the power of product log of natural log of 7. And this is what you are going to get. So, just like what we did earlier on, if you have t power t equals 7, it simply means 2.3165 power 2.3165 will give you an approximate value of 7. So this becomes the value that satisfies that equation. So you solve it this way instead of testing it and wasting your time. So guys, this is how you can solve this type of exponential problem step by step. And that is it. And I believe you enjoyed this video. So don't forget to subscribe and share. Thank you and goodbye.